Hello everyone, we are going to provide you answers for self-study questions covering lecture 4 and 5 materials about chemical bonding and structure. So in problem 1 you are given 3 elements with known proton numbers, and the question overall will be about the type of bonding between these elements and the physical property of the compounds which forms from these elements. So let's start with writing the electronic structure for these elements. So X has 9 electrons in overall, so coming from proton number. Okay, so 2 in the innermost shell and 7 in the outermost shell. So Y has 19 electrons, so 2, 8, 8 and 1 in the valence shell. So Z 34 electrons, so 2, 8, 18, including 3d electrons and 6 in the outermost shell. Now we will predict the bonding type between these elements by referring to the valence electrons. Okay. So X has 7 valence electrons. Okay, that means it is in group 7a, halogen group. Z has 6 electrons in the valence shell, therefore it is in group 6a. The bonding type between the elements depends on the electronegativity difference between these elements. Okay, so if the difference is low, the bonding will be a covalent type of bonding. And if the difference is big, more than 1.7, it will form an ionic bond. So if we know the positions of these elements in the table, so X is in group 7 and Z is in group 6. So they are located close to each other, therefore the difference between the electronegativity values will be low, so leading to a covalent type of bonding. It might be a polar or non-polar covalent bond depending on the actual difference. So if it is lower than 0.3, it will be a non-polar covalent bond. If it is bigger than 0.3, it will form a polar covalent bond. But these values, 0.3, 1.7, they are not exact values. They are just approximate values to give you idea what type of bonding will be formed. So we know X is in group 7a. Okay. So Y is in group 1 because it has 1 valence electron. So it's an alkali metal. So the difference between the electronegativity values will be big because they are located very far from each other. So group 1 element and group 7 element. So very far from each other, leading to a big difference. Therefore, the bonding will be an ionic bond. So difference is big enough for one element with a high electronegativity value to completely pull the electron to itself from the other metal, from the other element. Okay, now let's draw dot and cross diagrams for these compounds. So let's start from the easy one. It's easy for me. Okay, from the ionic bond. So X and Y. Okay, and we know Y is in group 1. So it is a metal. So let's put it first. So Y. Okay, and it has 1 electron in the valence shell only. Okay, 1. And X is in group 7, so 7 electrons in the valence shell. So 1, 2, 3, 4, 5, 6, 7. Okay, and probably X will be smaller in size because it has a few number of levels, and Y has more energy levels. So due to shielding effect, it will have a bigger size. Okay, so X will have high electronegativity value, so it will pull the electron from Y. Okay, so we have a complete transfer in ionic bond. So Y will form a cation having a smaller size than its corresponding atom. Okay, and X will gain a bigger size due to extra electron. Okay, so it's on 7 electrons and 1 extra electron from Y element. Okay, and due to extra electron, it will have a negative charge. So now we formed an ionic bond. Okay, next compound, X and Z. I will start with the element which has a low electronegativity value. So if we know the trend in the electronegativity values in the table, so it increases from bottom to top and from left to write, yeah? So Z is in group 6, X is in group 7. That means Z will have low electronegativity value than X. Okay, therefore I will start with Z. So Z has 6 electrons in the valence shell. So I will put all these electrons on the 4 corners. First by putting single and then starting pairing up. Okay, so and we see that that has 2 unpaired electrons. Therefore, it will usually form 2 covalent bonds. Okay? So it will form a covalent bond. Okay, we know it's a covalent bond with the X element by sharing the electron. Okay. And X is on 7 electrons, represented by dots, and another covalent bond with another X element. So now Z and X gained an octet stable state. So Z has now 1, 2, 3, 4, 5, 6, 7, 8 electrons, and similarly X gained octet state. So 1, 2, 3, 4, 5, 6, 7, 8 electrons in the valence shell. So we can see that Z formed a bent shape. So one single covalent bond with X, another bond with X, and 2 the lone pairs. Okay, so lone pair will push the bonds, the bonded electrons down. Okay, forming a bent shape. So this is one possibility for X and Z, but there is another possibility for Z to form another shape, another compound, when it uses all its 6 electrons in the valence shell. So here it used only 2 unpaired electrons, but there might be a case when it will use all 6 electrons. So then it will form an octahedral shape. So 2 in the y-axis and other 4 electrons in the equatorial axis. Okay, and 6 bonds with 6 X elements. So here X, so here X. So all covalent bonds sharing electrons. Okay, and let's put X its own electrons. So okay, so here it formed an octahedral shape. So you can just rewrite it clearly here. So Z forming an octahedral compound. A symmetrical octahedral compound. Okay, now let's compare the physical properties of these compounds. So we're comparing X and Z with X and Y. Okay, and we know X and Z formed a covalent compound, and Y formed an ionic compound. Okay, and we know that ionic compounds, they have giant structure, and covalent compounds, they usually have simple molecular structure, except those few examples with giant covalent structures such as diamond, graphite, and silicon dioxide. Okay, so volatility we can refer to the boiling point. So if a compound has low boiling point, okay, that means it will escape to the gas phase easily. Okay, if it has low boiling point, that means the compound will be volatile. Okay, so ionic compound X and Y is ionic. That means it will have high boiling point because it is difficult to break the giant structure, the intramolecular bonding. Okay, therefore this X and Y is not volatile, so it will not easily escape or be transferred to a gas phase from a solid to the gas phase at room temperature. So it's not volatile. X and Z is equivalent compound. That means it's equivalent compound. So they are held together by weak intermolecular forces due to simple molecular structure. So they are held by weak intermolecular forces. Okay, so therefore it is easy to break intermolecular forces, and usually covalent compounds are volatile at room temperature. So they are volatile. Okay, electric conductivity, and we know ionic compounds, they do conduct electricity, but in molten. So they do conduct electricity in molten and aqueous state when it dissolved in water, aqueous state, when the ions are free to move. In the solid state, the ions are fixed at one place, so they cannot move, therefore cannot transfer the charge. Okay? X and Z is a covalent compound, therefore there is no free ions or free electrons for them to carry the charge. So no conductivity. So this does not conduct electricity. So do not conduct electricity. Okay. Solubility. So usually ionic compounds, they are soluble in water usually, but not all of them. Okay. So we can say usually soluble. Usually soluble in water. Okay. And X and Z. So it depends on the polarity of the molecule. Okay, so we can say X and Z. So here, in the first case, the molecule is a polar molecule overall due to its not symmetrical, asymmetrical shape. Okay, so therefore the compound will be a polar molecule. The molecule will be a polar molecule. But in this case, the second case, when the Z formed octahedral compound, the shape is symmetrical and it has same elements on each side. Therefore, the molecule will be symmetrical. Therefore, the molecule will be non-polar molecule. Okay. So X and Z, in the case of band shape, will probably be soluble in water because it's a polar molecule. So it has dipole-dipole interactions between the molecules. And dipole-dipole interactions it's similar as a hydrogen bond, so it will be a soluble. Okay, and X and Z in the case of octahedral shape. Okay, so it is non-polar, so it will probably it will have a van der Waals force. Okay, and the van der Waals force is not similar as hydrogen bond, so it will not interact with the hydrogen bond, so it will be insoluble in water.